Hello, welcome back to our talk on market structure. And in this video, we're going to be talking about monopoly. So just to give you a little recap, market structure is a measurement of competition, and market structure is part of a broader uh, picture, which is called the market environment. And the market environment has three elements. You've got market structure, we got right here, and then conduct and performance. And what this is called the SCP model. And what this says is if there's one change in an element of the SCP model, the other two will change. We're focusing on what happens when an industry's market structure changes. How does it affect conduct and performance? And what we're going to be doing is we're going to be starting with a particular market structure, monopoly. So, a monopoly is a industry where there's only one firm producing 100% of the uh, market supply. So there's no competition. And in this particular case, I want to draw a contrast between monopoly and perfect competition. In perfect competition, there are many, many, many firms, each firm producing an identical good, and each firm relatively small. There's free entry and exit into the industry. And this means any individual firm has no market power, and uh, the price elasticity facing each firm is infinite, meaning the demand curve for a firm in perfect competition is flat. And this is why marginal revenue is equal to price, which is also equal to demand for any perfectly competitive firm. This is not the case with monopoly. The reason why is because a monopoly represents the entire industry, and they do have market power. And this means in order for a firm to increase sales, they've got to lower price. In a perfectly competitive industry, any one firm doesn't have to lower price to increase sales because the presumption is they're so small they could sell their entire supply at the existing market price. So, in monopoly, marginal revenue and demand are no longer equal. And let's take a look at this. Let's look at this table right here. And you could see that this is the demand and this is the price. So when an oligopolist wants to sell one unit, they charge $13, right? Now, if you want to sell two units, you've got to lower your price to $12. But keep in mind, if you're going to lower your price to get one more unit of sales from one to two, you've got to lower your price two times. You've got to lower your price for the second customer and the first customer. So this means you're cutting price twice to the new customer and to the previous customer. And you could see how this affects total revenue. When price goes down $1, marginal revenue drops $2. And the reason why it's dropping $2 is because you're cutting price for the new customer and the previous customers. And this is why marginal revenue is always lower than price. Now let's look at this graphically. So here's your demand curve, which tracks price. That's the capital letters right here. That's the red curve. And you could see that as price falls from capital A, capital B, capital C, marginal revenue is falling faster. How much faster? Twice as fast. Remember, for every $1 cut in price from 13 to 12, marginal revenue falls $2 from 13 to 11. So when you cut price from B to C, that's 12 to 11. Marginal revenue drops from 11 to 9. It drops 2. So you can see the marginal revenue curve has a slope that's twice as steep as the demand curve. Now again, from a common sense point of view, all this means is your change in revenue is falling faster. Your change in total revenue is falling faster than your fall in price, cut in price. This is because you're cutting price twice. for the new customer and for the old customers. Now, this complicates things a little bit when we want to solve for um, the profit maximizing rate of output and price. So now, if a monopolist was able to charge different prices to different customers, you're going to see a far different outcome when it comes to total revenue. So we call this price discrimination. If a monopolist was able to charge each firm, each person, their maximum price, in economics we call this reservation price, you're going to see that they're going to charge the first customer $13, and they're going to charge the second customer 12, but continue to charge the first customer 13. So in other words, this is not one price for every customer. It's an individual price for individual customers. So let's go to how do we determine how does a monopolist determine price charged, output produced, total revenue, total cost, and profit? Well, I'm going to give you 7 steps to figure this out graphically. So we're going to use the MR equals MC rule, and we're going to see that as a monopolist increases its um, price, where was okay? I'm sorry. Here we go. Here we've got a demand curve, and you could see that when when we change price, so if we go from 0 units to 100 units, that goes from 80 to 60. So when the monopolist lowers price to sell more, you can see um, revenue is increasing, and then they go from 60 to 40, demand increases, and you can see it increases. But once they get past point B, if they lower price again, they do sell more, but look what happens. Revenue starts to drop. That tells you something about elasticity. Ela Prices are elastic at the upper end of a demand curve, but they're inelastic at the lower end of the demand curve. So, and this is what we see here. So this is the symbol for elasticity. Elasticity equals 3, which is greater than 1, elastic. And here at the lower end, elasticity is less than 1, inelastic. Now, let's um, figure out how to determine price, output, and profit. So what I'm going to give you here is I'm going to give you a demand curve, a marginal revenue curve, and this black line is the average total cost curve, and this red curve is the marginal cost curve. This is S for short run marginal cost curve. And what we're going to do is I'm going to give you 7 steps to find P, Q, total revenue, total cost, and profit. So step 1 is find where MR equals MC. And you could find that where the 2 lines cross. You see that step 1? And in order to find output, you simply move down until you get to the horizontal axis. That's step 2. See? I went from 1 to 2. I moved down. Let me get my laser pointer out here. So this was step 1, then I moved down to step 2. So I have Q. I found one of the things that we need. Now, how do we determine the price charged for this output? Well, step 3 is go back to the demand curve. See, I went back to the demand curve. And now I can establish price by moving to the left. That's step 4. So now I've got the price charged. Well, now I've got price, now I've got Q. So this square right here is total revenue. So P times Q gives me total revenue. Now, how do I find total cost? Well, total cost is ATC times Q. So to find that, I go back to the demand curve. That's step 5. Then I find the ATC curve. I either go up or down. And in this case, I go down to find the ATC curve. See how I'm right on the ATC, this black line right here? And now I establish the average total cost for this level of output, and I move over to the left. That's step 7. Now I've got my ATC and I've got my output. So ATC times Q, this square is total cost. So if the larger square is total revenue and this is total cost, the difference must be profit. Now you could calculate profit one of two ways. You could total revenue minus total cost, or you simply uh, P minus ATC is going to give you the vertical distance here, times Q is going to give you the area of this shaded area. So that's your 7 steps to determine price charged, output produced, total revenue, total cost, and profit. Now, how can we do this um, mathematically? Well, let me go to this problem right here. Let me give you a demand curve that looks like this. This is the equation for the demand curve. And let's assume we have average total cost equals 4. Notice how it's forced, which means ATC is constant. So if every single unit you produce has an ATC of 4, that means your marginal cost is always 4. Because what's the change in total cost if total cost is always 4? That means your change in total cost will be 4. So in this particular case, ATC equals 4, which is also equal to MC, marginal cost. Now, how do we do this? Well, remember before, step 1 in that graph was to find where MR equals MC. Well, let's first determine our marginal revenue equation, and we'll set that to our marginal cost equation. Now, what is marginal revenue? Marginal revenue is the first derivative of total revenue. And what is total revenue? P times Q. Well, we've got P, so if we take this, which is equal to P, and multiply it by Q, that will give us our total revenue equation. If we take the first derivative of that, that will give us our marginal revenue. So watch. See what I just did? I took P times Q, which this is P, and I multiplied it by Q. So I distribute the Q, and now we've got a total revenue equation right here. All I do is take the first derivative of this, and that turns into 20 minus 4Q. Now, for more information on how to do this, I've posted some instructional videos on the class site. Now, we just got to set this equal to our marginal cost curve, our marginal cost equation, which is simply 4. So this is marginal revenue equals marginal cost. I solve for Q, and I get Q equals 4. Now I have output. To figure out price, I simply plug this back into the demand equation. And you can see this was P, right? I plug in 4 quantity, and I get a price of 12. Now to figure out my total revenue, P times Q, that's total revenue. Now for my total cost, it's going to be ATC times Q, 4 times 4. So total revenue minus total cost equals profit. So there you've got how to solve this graphically for a monopoly and how to solve it mathematically. Now there are some more examples in the problem set, but I think you'll find this instructional video to be helpful.